Okay, thanks for coming today. So for those of you who don't know me, my name is Adam Tarando. I'm a research ecologist with the U.S. Geological Survey, Southeast Climate Science Center, which is part of North Carolina State University, and I'm adjunct faculty in applied ecology here. And so we were really happy to be able to bring our speaker in today, Catherine Hayhoe. And I've known Catherine for quite a few years now, since I think about 2009, something like that. And Catherine is an associate professor in the Department of Political Science and director of the Climate Science Center at Texas Tech University, which is part of the Department of Interior's South Central Climate Science Center, so one of our sister science centers over in Texas. Her research currently focuses on establishing a scientific basis for assessing the regional to local scale impacts of climate change on human systems and the natural environment. A native of Ontario, Canada, Catherine first came to the U.S. for her graduate studies in atmospheric science at the University of Illinois, go Illini, recognizing the need for high-resolution climate projections to integrate into impact studies in areas ranging from ecosystems to energy. Her research focused on surveying and comparing a broad range of the statistical downscaling methods often used to generate these climate projections. And since then, her work has appeared in numerous publications and many of the primary government reports dealing with climate change, such as the National Climate Assessment and reports from the National Academy of Sciences. And these are the reports that we really base a lot of our policy and action or lack thereof on climate change. And Catherine has a really strong public presence as well. She's authored a book together with her husband called Climate for Change, Global Warming Facts for Faith-Based Decisions. And you might have seen her work in the media. Her work has been featured on the Showtime documentary series, Years of Living Dangerously, the PBS series, The Secret Life of Scientists and Engineers, and in articles appearing in On Earth, Grist, the LA Times, Climate Progress, and others. And in 2014, she was awarded the American Geophysical Union's Climate Communication Prize and was named one of Time Magazine's 100 Most Influential People. So we're going to do something a little bit different today, in that Catherine's going to speak for about 20-25 minutes, and then we're actually going to have a panel discussion immediately following, and we have 3 guests here from outside of the university that are going to be speaking to some of these really sort of big issues when it comes to climate change, and how do we, if we think this is a problem for society, how do we do anything about it, and what does that mean in terms of the science community and other communities like the faith community. So, please stick around for that. We're going to go a little bit longer today too, up until about 4:45 or 5 today. So without further ado, here's Catherine Hayhoe to present Facts Are Not Enough. Why does a climate scientist care about a faith-based response to the impacts of climate change?
Thank you for that introduction, Adam. And thank you, everybody, for coming. Tonight, this afternoon, whoa, there it goes. This afternoon, I've been up since really early, so it sort of feels like tonight already. This afternoon, I'm not talking about my main research area. So my main research area is climate projections, especially how to integrate climate projections. That sounds a little better, doesn't it? Okay. It was kind of hissing a little bit. I think I'll hold it down a bit. How to integrate climate projections into future planning. So to that end, I work with a lot of cities, a lot of different agencies at the state or the federal level to try to help them prepare for a future, well, still uncertain, that we know will not look like the past. But today I'm going to talk at Jerry's request, who's unfortunately not here. But what he asked me to talk about instead was my accidental second career, which is talking about how we think and talk about the issue of climate change. and how it isn't necessarily just a head issue. It's actually got a lot to do with what is in our hearts too. And to move forward on this issue, we have to somehow be able to connect the two, because just going with what's up here is not enough. So the subtitle of this presentation is not just necessarily what you read. The subtitle is also, let's see, if I click this, species. No, what do you, there we go. The subtitle may also just as well be, I don't believe in global warming. Because we're often asked if we believe in global warming. I'm asked that all the time. Why are we asked that? To quote Lindsey Graham from the South, not from North Carolina, to quote Lindsey Graham, he said, the problem is that Al Gore has taken this climate change thing and turned it into a religion. How do we know that's true? We just have to Google it online and we find the proof. I'm waiting to see a version of this picture where they Photoshop my head onto somebody in the choir. I haven't got that yet, but I'm sure it's coming. The issue is, though, that, as this article by Rebecca Lieber said last year, you can't believe in climate change because it is not a religion, is it? It's a scientific fact. And as Dan Barker said very insightfully, science does not demand belief. So we scientists, at least speaking for myself, maybe you do this, but most scientists do not join hands every Sunday singing, yes, gravity is real, I will have faith. Anybody do? No. In other words, if we step off a cliff, as this horse just did, regardless of whether we think climate change is real, regardless of whether we think gravity is real or not, we're going down anyways, right? Doesn't matter what the horse is thinking. So where does belief come into this? That's what I want to talk about today. Let's look at our definitions first. If we look at the definition of science, Google, we all heard, right, how our brains are storing less information now because Google stores it for us. Well, here's our Google definitions. Google tells us science is what? The systematic study of the behavior of the physical world, so the world around us that we can see and touch and taste and smell and measure, through observing and experimenting. What is faith? Faith is a strong belief that is based on spiritual apprehension rather than proof. Now, this is a definition from Google, but what struck me is we find almost the same definition when we look in the Bible, for example. There's a verse in the Bible in the book of Hebrews that says faith is the substance of things that are hoped for in the future. They aren't here now, present. The evidence of things that are not seen. And if I could just amend this without being too heretical, I would add the second half of the verse. Science is the substance of things here and now, the evidence of things that we can observe and experiment with. So says Google. So what I want to suggest today to you is the idea that faith and science are not in competition. It is not a case of believing in climate change or not believing in it. They're two alternate and they are mutually exclusive, but they're not two different systems of belief where you have to pick one. We need them both when it comes to difficult, thorny issues like climate change. So what I want to do is I want to talk about what science can tell us and what science cannot tell us. We're going to start with what science can tell us because for scientists that's easiest. What can science tell us? Number one, it can tell us that climate is changing. That's what science can tell us. It can tell us that the planet is warming. Oops, didn't global warming stop? I thought I heard that in the last debate. No, science can tell us that climate is defined as the average over 20 to 30 years or more, not just a few years that you pick because it doesn't look like it's gotten that much warmer. When we look at the whole temperature record, we see that actually 2014 was the warmest year on record. 2015 is now the warmest year on record. We're seeing warm records being broken already this year. Now, one year might not be colder or warmer than the other, but over time, climate timescales, year after year, decade after decade, we see that the planet is warming, and we see the impacts around the country. This is an excerpt from a magazine that appeared at this exact time last year. I think it's probably too small for you to read, so what magazine do you think it might be from? Time magazine? No. Oh my gosh, somebody has great eyes. This is from Good Housekeeping magazine. How cool is that? Last year, our Climate Science Center got to help out with some articles on climate change in Good Housekeeping magazine. Why is it there? Read the top article. How climate change affects you. Climate change is here, and science can tell us that. Whether you live up in the Arctic on what used to be permanently frozen ground that is now crumbling and falling into the coast, whether you live in Australia, where they had a killer heat wave a couple of years ago so extreme they had to add a new color to their temperature map, 54 degrees Celsius, yeah, 129 Fahrenheit. Whether we live along the Gulf Coast that has always been prone to hurricanes, but we know now that warm ocean water powers the hurricanes, increasing the number of strong ones at the expense of the weak ones. Or whether we live where I do in Lubbock, Texas. This is a 6-lane highway, completely underwater with SUVs floating away, undergraduates in them. All around the world, even if we throw out our thermometers, even if we throw out our satellites, there's over 26,500 indicators of a warming planet, many of them in our own backyards in terms of when trees flower, what types of bugs we see, the fact that kudzu, which used to be known as the plant that ate the South, is now over the border into Canada because the winters aren't cold enough anymore, but it wasn't listed as an invasive species by Natural Resources Canada. They couldn't go in and take it off the guy's land. Science can tell us climate is changing, and now science can also tell us for the first time that it is us. It is our fingerprint. We know that in the past climate has changed due to the sun or natural cycles. Everybody knows that, including the people who post on my Facebook page every day. Isn't it just a natural cycle? I never thought of that. Wait a second, just go down 2 more posts and it's right there. No, not a natural cycle. But we know, for example, that the temperature of the Earth, that's the orange line, and the energy from the sun have 0 correlation, or in fact a negative correlation, over the past 40 years or so. The sun's energy was going down while the temperature of the Earth was going up. So it can't be the sun, and we know that. We know that in terms of the glacial cycle, and this is an image I was talking about with the group that we were discussing before. What do you do when you're in a room where most of the people don't think that the world is old? How do you talk about climate change? This is how you talk about climate change. Because is not the evidence of the Industrial Revolution crystal clear in this figure? We can see that the world used to be gradually cooling in preparation for eventually heading into the next glacial maximum, which is the next thing on our orbital calendar. I should say was the next thing on our orbital calendar, until something happened. And lastly, we know why it happened. It's because heat-trapping gases, carbon dioxide, methane, they've been building up in our atmosphere ever since the Industrial Revolution. We know that when we burn them, they produce carbon dioxide. When we burn coal and gas and oil. We know that we've been producing a lot of this stuff because we have records. This is what science can tell us. We know that these gases trap heat with their vibrational and rotational bands. They absorb heat coming up from the Earth, and they re-radiate it in all directions, which effectively means a lot more of it gets trapped inside than outside. We know that, and that's what science can tell us. And here's what we also know, and that's that we've known about this for a really long time. These are the original climate scientists right here. And you are not looking at pictures of Adam and me and other people dressed up in old-timey outfits with fake facial hair. These are the real guys. Fourier discovered the greenhouse effect, the fact that our planet would be 60 degrees colder than it is now if we didn't have this amazing natural blanket. Tyndall discovered that coal mining and other fossil fuel-related activities produce these gases. The guy in the middle, Arrhenius, is my personal hero because he was the first climate modeler. He built a climate model by hand from basic physics and calculated how much the Earth would warm if we doubled or tripled carbon dioxide levels in the atmosphere. He started in 1890. He finished in 1892. Somewhere around about the second Christmas, his wife packed up the family and left. So this is very near and dear to my heart because it makes me appreciate computers. You set up the simulation and you go home and you have dinner. This guy was the first person to publish a paper in 1937 measuring the observed increase in the temperature of the Earth in response to burning fossil fuels, and our carbon dioxide records were started by Charles Keeling. We also know, and science can tell us, that climate scientists are very certain that humans are the primary cause of climate change today, but science, social science, can tell us that that's not what people think. People think we don't know what we're talking about. Because when you turn on the TV, what do you see? Two heads arguing with each other. When scientists talk to each other, what do we talk about? What we don't know. What's the third thing science can tell us? What was the first? It's real. The second, it's us. The third, our choices matter. What am I talking about here? Well, first of all, we know that the impacts are already here today, and that was what I think the Years of Living Dangerously did so beautifully. They're got season 2, they're filming it right now, and it's going to be out, I think, in next fall, which is pretty cool. It puts a human face on climate change. We also know, though, that future change depends on our choices. If we continue to depend on fossil fuels for most of our energy, we're going to be following a much higher and faster pathway to change. Whereas if we can transition in a sensible, sustainable way to clean sources of energy that don't produce carbon dioxide and methane, we're going to be looking at a much safer future that will be easier to prepare for. Now, as scientists, we know that this matters. Science can tell us that the warming that we're going to see in the United States by the end of the century is going to be bigger under a higher scenario versus a lower scenario. What type of uncertainty is this? This is human uncertainty. We know, and this is a paper that was published last year, we know that as the world gets warmer by 1 or 2 or 3 or 4 degrees, the risk of drought across much of central United States and even Canada increases. So when the nations go to Paris to decide where they want to be, what type of target we're going to have, this is the type of information that people look at to say, is 2 degrees okay? Will we be okay at 2 degrees? What happens if we get up to 3 degrees? Maybe we should go lower. This is looking at drought risk. This is some work by Dave Lobel looking at crop risk. Changes in the 5 biggest types of crops in the world as the world warms by 1 or 2 or 3 or 4 degrees. Science can tell us what is likely to happen at different amounts of global change. But this is where the science stops. Why? Because although there are many sources of uncertainty in future projections, science is sort of like this compass. It can tell us where is north and south and east and west, and don't tell me if I just pointed the wrong direction. But it can't tell us which is the safe place to go to. That's not what a compass does. So 25 years ago, the United Nations Framework Convention on Climate Change was signed by almost every country in the world, including the United States, in which people agreed to stabilize greenhouse gases at a level that would prevent dangerous human interference with the climate system. 25 years ago, everybody agreed to it. So why haven't we done it? It's because we can't agree what level that is. What level is dangerous is not a scientific question. If we go up to the Arctic and we ask people whose village is crumbling and falling into the ocean, have we reached dangerous warming, what do you think they would say? Yes. I asked a health expert this summer, studies health impacts around the world for the World Meteorological Organization, the WHO. I asked Carrie, at what point do you, as a health expert, think we have reached dangerous warming? And she looked at me like I had 2 heads, and she said, did you not just read the news this week? 8,000 people died in India from a heat wave. I said, oh, so we've reached it. She said, yes. But if you live in a nice, comfortable area with a nice, comfortable climate, and things are just getting a bit warmer, and so far you haven't had any major negative impacts, and you say, have you reached a dangerous level? People would say no. And in the United States, if you went to Congress and you asked them, have we reached a dangerous level of warming, they'd say, are you crazy? It's not science. It's something else. You may say, do I really, agree with you on this? Well, let me ask you a question. How many cigarettes are too many cigarettes? You may say one is too many. Well, what if you've been a smoker already for 20 years? Should you keep on going? How many more cigarettes can you have until you get lung cancer? You can have 999 cigarettes, but the 1,000th one will give you lung cancer? There is no magic threshold for fossil fuel emissions, despite what you might read in Scientific American. There is no magic number that if we get right up to this amount of global change, we'll be okay, and then just, a tenth of a degree over, and we're all going to hell in a handbasket. There is no such magic number, but we do know this, and the science can tell us this: the more we smoke, the greater the risk. The more fossil fuels we burn, the greater the risks. But the risks are related to us. Now, we know that the future is uncertain, and this is what I talk about a lot in my research. We know that we have natural variability in climate that makes it hard to predict the future. We know that our climate models are limited and incomplete. They're not perfect. We're always trying to improve them. We know that we've never conducted an experiment with our planet like we have before, so we're not quite sure when we kick it how far it's going to roll. And lastly, though, we don't know what our future emissions are going to be. So that's why we always use multiple different pathways of the future. And working with physical scientists, working with life scientists, often as scientists we'll look at this plot and we'll say, well, we can't run 4 different pictures of the future. Let's just pick the most likely one. And if this is a physical uncertainty, what is the most likely outcome? The most likely outcome is the middle, right? But is this a physical uncertainty? No. What are we looking at here? We're looking at different carbon emissions. What determines carbon emissions? Us, humans. So you could say, well, maybe what's going to happen is either we'll do something about climate change, a bimodal distribution, or we'll do nothing about climate change. Or if I had to put my money on actually guessing which pathway we're going to follow, I know already we're doing a pretty good job of following the red pathway so far, but I also know that increasing risk of disruptions are coming up that will scare the pants off people. And so if I had to guess, I'd say we're going to probably start to decouple from the red, slowly start going up a little bit lower than the red, then kind of have a collective oh shit moment as a complete country or world and get down as fast as we can to as low as we can go, which is not even a scenario that's on this plot. The point there is what determines where we are is not science. It's us. And it's not so much what's up here, it's what's in here or possibly in your liver if that's where you think the emotions reside. So John Holdren, the president of Science Advisors, said something very insightful. He said, at this point, we have 3 choices. We can reduce our emissions, mitigate. We can prepare for a different future, adapt. And he said something that is not a science word. And we can suffer. We are going to do some of each. The question is just what the mix will be. Because the more we reduce our emissions, the less we'll have to prepare for a different future, and the less suffering there will be. Suffering is not a word that's familiar to scientists, but suffering is a word that is intimately familiar to people of faith. Much of faith, the purpose of much of our faith sometimes it seems like, is to get us through the suffering that occurs in this world that is beyond what science can help with. Why does this matter? Well, in the United States, numbers go up and down from year to year. This is the Pew Foundation looking at 2007 and 2014. In 2014, though, we have 15% of people in the U.S. are mainline Protestant, 21% are Catholic, 25% are evangelical Protestant, 22.8% are unaffiliated. So what do we have? And then 6% are other faiths. Almost 80% of people in the United States belong to some type of faith. Almost 80%. If you look around the world, it's even bigger. Look at those numbers. 16% are unaffiliated, and the rest are affiliated with a specific faith. Why does that matter? It matters because often what's in here comes from our faith. And so that is why I think we need to talk about our faith. And I'm going to start off by talking about the Christian faith from a Protestant perspective. And then we're going to bring up the panel in just a couple of minutes to reflect on what we just talked about, the crisis that is happening to our planet, from the values that they have in their community. So I once asked the head of the National Association of Evangelicals, what is the definition of an evangelical? And you'll be happy to know that the National Association has a fantastic statement on climate change, by the way. I asked him, what is the definition of an evangelical? And he said, well, an evangelical is somebody who takes the Bible seriously. I said, all right, let's look at what the Bible says. Genesis, God made people in his image to be responsible for every living thing that moves on the face of the earth. That's pretty clear. And if you actually believe what it says, that leads to the idea of creation care, caring for the world around us. There's more than that, though. If we look at where our carbon emissions have come from over the past 100 years, now, on a year-to-year basis, China did overtake the United States a couple of years ago, but on a person-to-person basis, no way. Canada, U.S., and Australia are top in terms of per-person emissions. This is who's driving the problem, and these are who are experiencing the impact. So there's more to it than just caring about birds, bugs, and bees. And I shouldn't say just, because those are very important. The reality is that if we care about poverty, hunger, lack of access to resources, and education, if we don't recognize that climate change is affecting those things, affecting crop yields, affecting water contamination, affecting the spread of disease, we're going to be pouring all of our efforts into a leaky bucket with holes in it, and those holes are being made by climate change. And climate change is making new holes all the time. We have to patch the holes in the bucket to fix these huge global issues that just about every single person on this planet cares about. So going back to the Bible, we have a lot of signs by God in Texas. For some reason, God seems to put signs up in Texas. Some of them really make me question what God is putting up signs in Texas, because they don't quite seem like they come from the Bible, but I like this one. That love thy neighbor thing, I meant it. Who is our neighbor today? Our neighbor today is a global neighbor. We're being impacted together with our neighbors by climate change. And the Pope gets this, right? He put out an encyclical this summer talking about how this warming is being caused by enormous consumption of some wealthy nations with repercussions in the poorest places on the planet. I didn't show the Pope that map I made, but he already got it. We care about climate change because it affects people, especially the poorest and most vulnerable among us. So why do we have this situation in the United States? We could talk about this for a whole long time, and I really don't know what it has to do with donkeys. In the United States, there is this huge revulsion against the issue of climate change, but it's because it raises fears that date back to the American Revolution, right? What was the American Revolution about? Taxes, tyranny, injustice, government telling you what to do. And so then again, also, if you look to the Christian faith, you can say, hey, guess what? That's not coming from God. That spirit of fear is not coming from God. Christians are supposed to have love, power, and, as a scientist, this is my favorite, a sound mind to make good decisions. Wouldn't that be nice? So this is the vice president of the National Association of Evangelicals, and he said exactly this. He said, many evangelicals oppose action to slow climate change, not on a religious basis, but politically, because they believe the government wants to take away their freedom. Going back to Lindsey Graham, again, I'm not picking on Lindsey Graham. He just says a lot of good things. He says, you know, climate change is not a religious problem for me. It is an economic problem. And then we're starting to get at the tip of the iceberg there. And I would say, when we talk about climate change, the most important thing I've learned, and the steepest learning curve I have had, is in learning to talk about solutions. Because if we talk about this like a problem, we're not going to move forward. But if we talk about it like an opportunity, we will. Because that is what motivates our hearts, is hope, not fear. Inspiration, not despair. So as a scientist, what do I see when I look at the world around me? A lot of my colleagues, you can even read articles that were written just this past year, have existentialist despair when they think of the climate system, have anxiety disorders when we see what's happening to our world. There's not a lot of hope coming out of climate science. But there is a lot of hope coming out of where? Faith, solutions, actions, when people's hearts are engaged. So let me say to you again, I don't think that faith and science are in competition. But I also think that we need them both. We need our heads to inform our decisions, but we need our hearts to engage on these decisions. To quote one of my favorite scientists, Jane Goodall, it is only when our human brain and our heart work together in harmony that we can achieve our full potential. Thank you.